Remember, the second limit we were looking at says that the limit as x approaches 0 of the cosine of x minus 1 over x is equal to 0. This one starts out actually by writing a limit. The limit as x approaches 0 of the cosine of x minus 1 over x. We're going to multiply numerator and denominator by the conjugate of the numerator. Our result is the limit as x approaches 0 of the cosine squared of x minus 1 divided by x times the cosine of x plus 1. Now that numerator, I'll write down the limit as x approaches 0. That numerator is the negative of the sine squared of x. The denominator, nothing special. X times the quantity of cosine of x plus 1. But I can take the negative and pull it out front. We have a limit law that says we can do that. And then I've got the limit as x approaches 0. What I'm going to do is I'm going to take the sine squared of x and I'm going to split it up into the sine of x times the sine of x. Why the gap? You'll see in just a minute. The denominator I'm going to split up as well. So I have x times the quantity cosine x plus 1. So I have sine of x over x, and then sine of x over the cosine of x plus 1. Now, there's a limit law that says the limit of a product is the product of the limits, provided the individual limits exist. Now, we know that the first limit is equal to 1. We just saw that. So this is equal to negative, because of that negative out front, but it's about to not matter at all. When I substitute x equals 0 in the denominator, I get 2. In the numerator, I get 0. So this is 0 over 2, isn't it? Well, that equals 0, which shows that the second limit exists, and this is the result that we were after. If we go back here, we saw that the trigonometric limit involving the cosine function was supposed to turn out to be 0. We're going to find a limit involving a sine function, and remember we have two trigonometric limits. So we have here the limit as x approaches 0 of the sine of 3x times the sine of 5x over x squared. And the goal is to make these look like either the limit involving the sine function or the limit involving the cosine function. My money's on the sine function. Notice that in the limit expression, or the limit equation for the sine function, we have the sine of x over x. And what I want to point out here is that the argument in the numerator, the sine of x, is the same as the denominator, x. I'm going to make an assumption here that both limits exist, and I'm going to use the limit law that says that I can apply a limit to the factors of a product. So the limit as x approaches 0 of the sine of 3x over x, I'm splitting up the x squared, times the limit as x approaches 0 of the sine of 5x over x. See, now these are starting to look like this over here, but not quite, because in the sine of 3x over x, the argument of the sine function doesn't match the denominator. Likewise for the sine of 5x over x. But I can fix that by my voice went out there, by multiplying by a constant. And in fact, for the sine of 3x over x, I can multiply the numerator and denominator by 3. And I end up with 3 times the limit as x approaches 0 of the sine of 3x over 3x. I can likewise fix the sine of 5x over x by multiplying the numerator and denominator by 5. I can pull the 5 out front of that factor and end up with 5 times the limit as x approaches 0 of the sine of 5x over 5x. The limits don't affect the 3 or the 5, so I can pull them out front entirely and call it 15. And then I have the limit as x approaches 0 of the sine of 3x over 3x times the limit as x approaches 0 of the sine of 5x over 5x. And because each of those arguments match for the individual fractions, I know that those limits both become 1. This result is 15. Now, if we're going to be technical, when we look at the limit as, say, for instance, x approaches 0 of the sine of 3x over 3x, what we should be doing is let theta equal 3x. Then, as x goes to 0, theta goes to 0. This limit then becomes the limit as theta approaches 0 of the sine of theta over theta, and that's what equals 1. I don't need you to give me this technically business. Some instructors would require that you do that. I'm not one of them. But the point is we need to make the arguments match, and then we can apply the limit